everybody. Today I'm a representative of the task group. I have to admit I didn't make the GDRs myself, but I have studied them and looked into them, and I would highlight the points that I think were most convenient to tell here. If I want to proceed, I have to do this one. In the end, 3 GDRs were made by 3 different colleagues of mine in the group. One is about micropiles. It's an analytical model. The second one is quite extensive. It's about a combined piled raft foundation. It's a numerical model by Bart from Germany. It covers two aspects that weren't as much as in the code as it is now. Pile raft is completely new, for example, and as well the numerical model is more placed in the code now. The last GGR is about board piles. And if I go to the first GGR, it was about micropiles, a very slender pile existing from a steel core with grout around it. You can see here on the left side how they are being set in the construction. And what he did is that because of the shape of the pile, he assumed there is no base resistance, and he only calculates shaft resistance in this example. And I think it was quite in the earlier days when this GGR was made. And the first thing you could see is the comparison of the design value that he obtained. In the Swiss code, it was obtained with this formula, and in the first draft of the Eurocode, it was obtained with the right one. And so basically, it's a comparison of the partial factors that are as a default in the code and what he was used to work with in Switzerland. And in the end, you could see that there's on the compression there's no difference at all, basically, and in tension there is a 10% difference, where the Swiss code would be a little more conservative. But again, this is about partial factors that are NDPs, so that could change a little. Something that I want to highlight is that apparently in the Swiss codes you obtain your design value directly from your characteristic value. As it is in the Eurocode now, you obtain it from your representative value. So if it would be a main value, then they're both the same. But if there's variation, yeah, you should do something with your partial factors. As well, what he did is that for this construction there are 2 dynamic tests done, and he made a comparison to the characteristic value that he obtained. And the characteristic value that he obtained was basically from textbook information that is provided in Switzerland, where he based on the ground conditions, he obtained in this graph directly a representative value for the shaft friction, basically, and he would come up with 150 kilonewtons per square meter, yeah, according to a certain Swiss standard. When you go to Annex C, there are some formulas provided where you can obtain the same kind of value. And yeah, what you could see that if you would fill in this formula, I hope you done it correctly, that you find much lower resistance than that you would expect from its conventional way of working. And as a general statement, I think that is happening on more places in the annexes, that there could be quite a difference what that what people are used to obtain from formulas as values than that they're in now. So as well here, the national of the countries should really look into that when they are making the national annexes. The second GGR was made was quite extensive, how do you say? And it was about a five-story building with columns on top of the foundation plate. I think it was around 1 meter thick, this foundation plate, with a core inside. And in this case, he combined a pile foundation with a pile raft foundation. So this would be like already in the old code to be provided, and now we have in the new code as well guidance on pile raft foundations. And you see here that he chose this way of working because if you see in the underlying ground, that here there is organic soft soil, a cohesive soil basically, and on the right side of the project there is only loose sand and medium dense sand to bear basically your loads. And yeah, that's why he called it, took this as a pile raft foundation and this only as a pile foundation. And if you do take then a deeper look into the code about numerical models, it's now presented in the first part of the code that you're able to calculate your settlements with a numerical model. And it as well says that you have to use two approaches. And in the first part, they call it the material factor approach and the effect factor approach. Somehow in the third part of the code, they renamed it to MFA-A as the material approach and MFA-B as the effects approach. And what you could see, if you go take a deeper look in the tables, that for the MFA-A, I will call it, the soil strength is unfactored, and the soil strength is unfactored, so only your loads are factored. And in MFA-B as well, your loads as your soil parameters are factored. So that already raises questions about why do you need to do them both. He said that it could be influence more the construction itself using MFA-A, but for a ground perspective, MFA-B would be always leading. Another thing that could be mentioned is that in the table the pile resistance is not factored. So in your model you're modeling your piles, and basically that would be logic if you have a direct link to your model and you have the right interface elements to model your shaft restriction for your shaft and your base basically. But if you would use like embedded model of embedded elements, yeah, you could argue that you also have to factor those. But as I'm saying, that is not covered in the Eurocode now. So as well in the National Annex there could be some enlightening about that. Bart, he describes step by step basically what you have to do making this numerical model, and I won't go over them step by step, but as well as said in the previous presentations, there's many cross references, ease of use. is not that great, was his argument, was his statement. And therefore it's sensitive for mistakes. As well, it was unclear if the forces from the numerical model have to be checked calculating the barrier capacity. So basically you model a pile that has a load on it in the end, and the code doesn't say that you have to verify that with like a pile method or whatever. So now it is assumed that it is it's covered in the model, but as well you could ask your questions about that as well. Let's say in the model the pile has a bearing capacity of 800 kilonewtons, and if you would calculate it with as a single pile method, you would get a lot less. You could raise questions about if then your model is sufficient, but that is not particularly mentioned in the code. Number 3 already talked about if MFA and B are both needed. MFA B would be only needed for a geotechnical point of view, and if you have to do them both, it would consume time. The standard partial factors that are given in the code now are a little optimistic in comparison to what is used in Germany. And in the end, here are some illustrations on how we made the model. So here you see your finite element model. Here is the organic layer, and here you see the loose sand and dense sand. And if you then look at the results, you could see here the settlements where we went that we were interested in, and then you see here that they're at the pile raft position. There's a little more settlement than in the only the pile bearing area. And yeah, you see here in the pile bearing area that there is no bearing by the soil in between. That is only occurring in the pile raft position. So it's basically not a conventional way of working, but the Eurocode now provides you with more guidance on this way of designing. The last GGR was about board piles. A lot of the same things that Patrick told were mentioned in this report. You see that in the National Annex C there is a lot of Dutch influence on the way of calculating your bearing capacity on CPTs. Don't want to go too much in detail about that, but as well, the thing that I want to point out is the downdrag. The code provides you in the annex with the possibility to only calculate downdrag in your equation when it exceeds your variable load. So if you have a very high variable load, you don't have to take downdrag into your calculation. This could be like a very intensive coordination because you will need your structural engineer as well to know if you would apply it or not. In the current Dutch practice, normally the downdrag is already taking off the bearing capacity in the geotechnical report. So that would be maybe a more conservative way of working, but it makes it more easy to have a separate role for the structural engineer and for the geotechnical engineer, basically. But there is room to optimize your design, basically. There was a lot talking about spatial variation in the other presentations. That the focus was on bearing capacity. There's no guidance how to deal with spatial variation of downdrag, but you could argue that you have the same kind of problem, or how do you want to call it, with down drag as well. And for now, it is it's like it's a main value is assumed to be the representative value. But as well, the national standard or the national annexes can provide something about that as well, that you could make correlation factors on down drag, for example. So that is a question we could answer for every country on its own. If you have any questions, I try to do my best to answer them.